Hey Pre-Cal, these are going to be your notes for section 1-6 day 1. We are going to begin looking at transformations, and so before getting too far into this video, what you might want to do is get some highlighters. I'm going to talk about the different types of transformations, and if you're a color-oriented person, if color helps you learn, pink and blue are going to be your go-to highlighters. If you don't have pink and blue, just any two different colors will work, and lock one in to match my pink and lock one in to match my blue. I will refer to the colors throughout this unit, as well as refer to them later on in following units as we kind of refer back to transformations. And then one other color just to kind of point out some important stuff, so I've chosen yellow. On your notes, you can see that I highlighted some stuff and that I want you to have memorized. I'll get to that a little bit later. Let me just go over the types of functions that we're looking at. So the first one is a constant function. It's going to look like y equals, and then this is going to be any number. It looks like the number it might be based on this graph, maybe 1.5, y equals 1.5, and that is a horizontal line. A linear function, y equals x, that is that's like the most basic linear function that there is. And then, of course, you should be somewhat familiar with what a quadratic looks like when graphed. This is the most basic parabola you will see. This is your square root function. Notice that you can't square root a negative number, so we can't include any negative x's in our graph. The graph starts with 0 because you can square root 0, and it goes into positive x's. Your basic cubic function passes through the origin. Your basic cube root function passes through the origin. This is the absolute value function. Notice without the absolute value bars, the graph of this would just be a line that goes through quadrant 3 and quadrant 1. But with the absolute value bars, it's saying, you know this line over here, this portion of the line that would have negative y's, we're no longer going to get negative y's out of this because we're forcing them to be positive. So all these negative y's are now forced to be positive y's. So that's why it gives the shape of a V graph. And then this is your reciprocal function. This is 1 over any number. Now, the number we have to exclude is 0 because you all know what happens when you divide by 0. So we're not going to include x equals 0. But all positive numbers are going to work, and it's going to result in a positive y value. All negative x's will work, and it's going to result in a negative y value. All negative x's will work, and it's going to result in a negative y value. That's why this graph is contained only in quadrants 1 and 3. Okay, now, everything that I've highlighted in yellow needs to be memorized. So, I need you to memorize the name of the parent function. I need you to memorize what the equation of the parent function looks like. And I need you to memorize what the graph of the parent function looks like. 3 things that need to be memorized on each function. Now keep in mind, when you are memorizing the equation, you can memorize the equation as a y equals equation or an f of x equation. Y'all know that means the same thing. So I don't really care if you call your parent function y equals x or f of x equals x. Doesn't matter to me. So those have to be memorized. Now, all this other stuff that's in each parent function box, I don't think you have to have that memorized, because let's say that I ask you a question just out of the blue. Hey, give me the domain for a linear function. Well, if you have the graph memorized, you can think well, this is what my graph looks like. If she's asking me for domain, how far left does this graph go? How far right does this graph go? Forever. My domain is all real numbers. If I say, give me the range for a parent quadratic, well, you should know what it looks like. So in your head should pop in this graph, and for range, you should say, okay, well, how far down does it go? How far up does it go? My range, my y's are going to start at 0, and then they're going to go up and up and up. They're going to go to infinity. So I totally think that just by visualizing each graph, you could answer these questions. Also, I have highlighted on a quadratic, it is nice to know the 5 basic points for a parent quadratic. So you need to know that your parent quadratic passes through the point 0, 0. You need to know that when you plug 1 into your equation and square it, you get a 1. So 1 comma 1 is a point. Also negative 1 when you square it is 1. And then 2 comma 2 squared is 4. Negative 2 comma and negative 2 squared is 4. So those are 5 points. I went ahead and highlighted them. I think you need to have those 5 points memorized as basic points on a parent quadratic. All right. Now, your notes for today, I've gone ahead and filled all of them out. Not the way I would typically do it in class, but I want people to be able to go through this video at their own pace. So, you know those nerds in class who just kind of half pay attention, and maybe they're doing their homework at the same time, and they ace every test, and you just want to kind of punch them. That was not me in high school, but they're out there. So those people can watch the video quickly. And then you've got the other kind of people who are like, wait, what'd you say? Slow down, I didn't get that written down. I don't understand what she just said. Do you understand what she just said? So for those people, you have the option of pausing the video and then writing, like copying what you see on your screen, start it back up, go through it, pause it, copy some more, and then if you have that moment where you say, wait, what did she just say? You can back it up. So you can each go through the video at your own pace. All right. It's going to be very important that when we talk about transformations, we have to go in a particular order, and you have to be able to recognize what is a vertical transformation and a horizontal transformation. So, first of all, I'm going to color code every vertical transformation. I am going to color code as blue. Everything vertical, I'm going to color code as blue. Everything horizontal, I'm going to color code as pink. Pick your colors, go with them. Stick with them throughout the whole, especially this section, tomorrow's section, but pretty much the whole chapter. All right. Now, any vertical transformations, these are going to take place outside of the parent function. Horizontal transformations are going to take place inside the parent function. Now, this can be hard for some of you to see. So what I'm going to try my best to do is let's look at a quadratic. You all should be really familiar with what a quadratic equation looks like. The parent equation for a quadratic is just y equals x squared. Okay? So keep in mind that whenever you choose an x value, pick an x, any x, maybe like, I don't know, 3. When you plug that 3 in, you don't do anything to the number that you plugged in before you square it. You just plug in the 3 and bam, you square it. If it wanted you to do anything else before squaring it, it would look like this. Pick an x, any x. Maybe you pick 3. Now watch. The x that you chose, you have to add 2 to it before you square it. I'm going to call that inside the function because this stuff that I've highlighted in pink is inside the parentheses that are being squared. This would be a horizontal transformation. It is inside the parentheses. Now, This one's going to be a vertical transformation because it's outside of the parent function. So think about this. Again, ready? Parent function. Pick a number, pick an x, any x, square it. There's nothing happening before you square it, okay? Now let's look at this slight transformation here. Ready? Pick an x, any x. Maybe you choose 3. Plug it in. What's the first thing you do? You square it. That's the parent function. You square it. Then do you do anything else? Yeah. After you square it and get 9, then you add 2 to that answer to get 11. So this is what I'm calling outside of the parent function. After you square it, then this is what you have to do to it. So again, inside is going to be within the parentheses, taking place before you square it. Outside is going to be anything outside the function. Could be hanging off at the end. It could be back here at the beginning because I know that you know your order of operations. Your order of operations says if there's a number out in front here, you know you plug in your x and you square it first and then you multiply. You know that exponents come before multiplication. So again, anything that occurs after you square that x is going to be a vertical transformation. And I would color code that blue. Okay, so I've given you some examples of some transformations, horizontal and vertical. Notice that I color coded these two pink. They're inside the parentheses. They take place before you square it. These two are outside of the squaring of the parent function, so those are going to be vertical transformations, and they take place after you square it. Now, a vertical transformation. So this parent function is going to be shifted up 2. It's a vertical shift. It says plus 2. So here's what's cool. See this equation? There is no plus anything on the end. We have those typical y values, those 5 ordered pairs that I showed you yesterday. Here there's a y value of 0. Here there's a y value of 1. Here there's a y value of 4. This is saying all the y values that you did have, we're now going to add 2 to them. So instead of 0, 1, and 4, now we've got 2, 3, and 6. We added 2 to them. Or on these, all the original y values that you got from squaring x, all the original y's, now we're going to take the original y's and we're going to subtract 2 from them. Okay? So vertical transformations are super easy to see, easy to do. It's the horizontal ones that get you. So this looks like, if I use the same philosophy, this is a horizontal transformation. So now you've got to think left, right, left versus right. It looks like you would add 2 to all of your x's. So it looks like all of these x's, you would add 2 and your graph would go 1, 2. But that's not true. For a horizontal transformation, everything is backwards from what you would think. So here you would think that it would go right 2. Tricked you, it goes left 2. Backwards from what you would think. This one you would think would go left 2. No. Every horizontal transformation is backwards from what you would think. So it's going to go right 2. So basically what that means is, and some of you are going to get this and it's going to go right over some of y'all's heads. To get the same y value from the parent function, I need to plug in an x that's 2 to the right to get the same result that I would get from the parent function. I would have to plug in an x that's 2 to the right to make this graph look like this graph. Again, went over some of y'all's heads. I realize that. It's okay. If you get it, that's great. If you don't, memorize. Horizontal transformations are backwards from what you would think. Vertical transformations, what you see is what you get. All right, and then, let's see, we've done horizontal shifts, up, down, or no, horizontal, left, right, vertical, up, down. Let's talk about flipping or reflecting a graph. So, look, here's a parent function. I need you to recognize that this negative sign is on the outside. And some of y'all still aren't good at this, but if you see this, whatever number you plug in for x, positive, negative, I don't care, you're supposed to square it first. Take it times itself. When you get your answer, then you make it negative. Or how about this? When you get your answer, then you multiply it by the negative 1 in front of it. Square it first, then deal with the negative. This one is different. I know it's cubic, but this negative is placed differently than this one is. This negative is placed on the inside, so you do this before doing the parent function, before cubing it. So whatever x you pick, let's say pick an x, any x. Let's say you pick 4. This says, ha, you picked 4. Let's put the negative on it and call it negative 4. Now let's take negative 4 times itself, So let's take negative 4 times negative 4 times negative 4. All right? So this is saying put the negative on before you do the parent function. So I'm calling this inside. That's a horizontal transformation. Outside, it's a vertical transformation. Now, some of you are going to memorize how it's flipped, and some of you are going to think it through every time. I'll be honest, I am not a memorizer. History dates, gone. I cannot memorize history dates. I have a hard time memorizing things in math. I don't need to. I just get it. I just understand. Let me help you get it. You ready? Think about your parent parabola, okay? Think about what it looks like. Now, ready? A parent parabola opens upward. See all those y values? Like 0 and then 1 and 2 and 3 and see all those y values? Okay, ready? Take all those y values and now all of a sudden make them negative. So when you take all these y values and you stick a negative on them, it's going to take your parabola from looking like this to now looking like this. All the positive y's are now negative y's. My parabola that was opening in the positive direction is now opening in the negative direction. So I can say that this has been reflected. I'm doing a vertical reflection. Now, which axis am I flipping over? Flipping over the x. Some of you are like, oh, but that can't be because x is the horizontal axis. I didn't say what the axis was, horizontal or vertical axis. I'm talking about a vertical flip. Flips over the x-axis. This one, all of your x's that were positive, now all, how do I do this? All of your x's that were positive, now think of all those x's being negative. See, there they are. All those x's that were negative, now think of all those x's being positive. There they are. So when you have a negative inside, it's going to be a horizontal reflection. You need to know which axis you're flipping over. Just visualize it. Visualize flipping horizontally. Which axis am I flipping over? I'm flipping over the y. So you can just visualize, okay, I would color code this blue. That means a vertical flip. That's over the x. I would color code this pink. That means a horizontal flip, flipping over the y. Memorize it or understand it. Those are your two choices. Okay, now, Let's talk about if there's a number in front of our function or a number in front of our variable. Now, I'm not real crazy about the way this is written because you all are so used to f of x equals, not having anything in front of f of x. But f of x right here just represents a function. So if this is confusing, you can think of this, just make up something for this if you think it's confusing. Maybe you want to think of this as 2, since it's a parabola, 2x squared. All right? So the f of x is just representing a function. What happens when we have a function like x squared and we put a 2 in front of it compared to the original? Or what happens when we have a function like x squared, whatever, and we put a 0.5 in front of it? So what you're going to see, or this is the 0.5 or 1/2, what you're going to see is when you stick a number out in front of the function, if you have a coefficient out there, all the y values that you get when you square x, so you pick a number, any number, you square it, like 3. Pick a number, square it, you get 9. That's your y value. Now, this says multiply that by 2. Oh, well, 9 is no longer my y value. Now my y value is 18. So this makes all your y values 2 times bigger, which makes your parabola quite stretchy. Same concept. Let's say you have 1/2 in front of your function. And again, maybe we're using x squared. I like x squared because I think you get it. So if x squared is your function, pick an x, any x. Hey, I think I'll pick 3. Okay, square it. 3 squared. Now times it by 1/2. Now all of your y values, instead of like 3 squared is 9, now it's 3 squared times 1/2. So it's 4 1/2. Now you're squishing vertically. So, summary. When you have a number greater than 1 as a coefficient of your function, it's going to be a vertical stretch. Your y values are going to become greater, stretching. When you have a number in front of your function, a coefficient that's a fraction, 1/2, 1/3, 7/8, 4/9, whatever, 0.8, it's going to compress. It's going to vertically compress. Bigger than 1, we're going to vertically stretch. Fraction between 0 and 1, we're going to vertically compress. Now, take that thinking and backwards it. So, and I know, again, this is written weird, but just what if your function is x squared, okay? Inside your function, inside the parentheses, what if there's a 2 there as a coefficient? Well, if you think about it the same way we just thought about that, now I've color-coded it pink. It's a horizontal, yes. The number is 2. You're like, oh, it's a horizontal stretch. No, because everything that's horizontal is backwards. This actually compresses horizontally by a factor of not 2. Now turn the 2 upside down. We're going to use the reciprocal of that. This is going to horizontally compress by a factor of 1/2. Not what you would think. Everything horizontally is backwards from what you would think. So, yep, there's a 2 in front of it. Looks like a horizontal stretch, but it's not. It's a horizontal compression, and the factor is 1/2. How about this one? This is on the inside of my function. Again, so if we're looking at the x squared function, the x has a coefficient of 1/2. Backwards from what you would think, 1/2. I would call this a horizontal stretch. The number 1/2 and turn it upside down. This is a horizontal stretch of 2. Backwards from what you would think, and we're always going to use the reciprocal. So when you highlight a coefficient pink, when you go to write your answer on your paper, I need you to turn that coefficient upside down. I need you to use the reciprocal of that. So here's what we're going to do. We're going to go through some examples, and today we're doing like the basic stuff, kind of like one thing at a time, just so you get good at it. And then tomorrow we're going to do several in one problem. So this is the absolute value function, and it told me to state what the parent function was. So at first I stated that it was absolute value, and then I thought, oh wait, maybe it wants the equation. I don't know, so I did both. This is the name, this is the equation for the parent function. And then here's what's happened. So notice, I hope you can recognize why I colored everything pink, because my function is absolute value. Can you see that the x and the -4 are inside the function? So I colored them pink. Now, here's what I'd like you to do. Look at what's pink. Start on the very left-hand side and work your way to the right. So here I go. Ready? Left-hand side. What's the first thing you see as you're working your way right? The first thing you see is a negative sign. Tell me what that does. The negative on the inside. Well, first of all, it's horizontal. So I think about a horizontal flip. Picture it in your mind. Horizontal flip. Which axis are we flipping over? We're flipping over the y. Okay, got that. Check. So we're moving our way right. So I got the negative. Check the 4. What does the 4 do? Well, the 4 is a horizontal. You would think it would be a stretch, don't you? But it's horizontal. So it's backwards. It's horizontal compression. And then a compression of what? Like, of what factor? 4. Turn that 4 upside down. Next one. Here's the question. It says, tell me what's the parent function. So I named it, wrote the equation. Wasn't really sure which one, so I did both. And then tell me what's going on. So notice that everything is in blue. There is nothing happening to the x before it gets cubed. So think about it. If you were to plug in an x, pick an x, any x, plug it in. What's the first thing you would do? You would cube it. So there's nothing horizontal, no horizontal transformations going on there. After you cubed it, then you would do the negative, the 5, and the +1. So notice I've colored these blue. These are outside of what's being cubed. So the first thing I need you to do is recognize why I colored it blue. Now, ready? We're going to start on the left-hand side, and we're going to work our way right. On the left, working our way right, let's talk about what we see that's highlighted with blue. The first thing that you see is a negative. Don't try to attach the negative with the number. The negative does its own thing. Let's talk about what the negative does, and then let's be done with it. So, blue, vertical, flip. Think, what does a vertical flip look like? This way, right? Vertical flip. What am I flipping over? Flipping over the x-axis. Glad you got that. Then what? Okay, so now we're finished. We are finished with the negative. Keep working your way right. Now I see a 5. What does the 5 do? Well, it's a vertical something. And remember, vertical, what you see is what you get. So this is going to be a vertical stretch of 5. Now we're finished with the 5. Keep working your way right. What's the next blue thing you see? +1. Vertical shift up 1. Next one, this is the square root function. So anything inside the root, I would color pink. So notice what I've done. This is all pink. This is inside. This is outside. This is blue. The name is the square root function. This is what the parent function looks like. There is something I need to tell you. Okay, so what we're going to do horizontal first. Horizontal always comes first. So think pink. We're going to do pink first. This is going to, backwards from what you think, this is going to be left 5. Pink first. Take care of all the transformations. There was only that one. Now you can start on the blue, and the only blue transformation is a vertical stretch of 3. Okay. And on this one, we've got a cubic function. Just kidding. We've got a quadratic. There we go. Do you see the parentheses and what's being squared? So everything that's being squared, everything that's in this first set of parentheses, I highlighted it pink, which means everything else needs to be blue. So this stuff outside the parentheses is blue, and this outside the parentheses is blue. This is a quadratic, that's the parent equation. And when you go to list the transformations, think pink. So we're going to do pink first. I'm going to list all the pink transformations first. I only see one. Remember, backwards from what you would think. So you would think left, but it's not. It's right 4. Got it. Check. Now let's do blue. When you go to switch to blue, we're going to start at the beginning and we're going to work our way right. Start at the beginning. What's the first thing you see? You see a half. The 1/2 is a coefficient. It means I've got a vertical compression of 1/2. Keep moving through until you see something else blue. Down 1. Okay. Now, a couple things I need to, I thought they could wait until tomorrow. They cannot. So, on transformations, somewhere, this is so important, about right here where it says, remember, horizontal is always opposite inside. So somewhere here, I need you to write down the order in which we're going to talk about transformations. So when you tell me all the transformations that happened, and there could be up to 6, you could say this happened, this happened, this happened, this happened, this happened, this happened. There could be up to 6 things that you have to tell me about. You have to tell me in the right order. So the acronym that I'm going to show you for the order is order horizontal, then vertical, left to right. So important. So important. What? I want to put it in a yellow highlighter so that you know it's something you have to memorize. Now, there are a couple of ways that you can memorize it. One is you can just memorize the acronym. Horizontal always comes first. Any type of horizontal transformation has to be stated before the blue transformation. And so I think by this point, we have, in our classes, we've probably all done some type of activity where you see that if you get your transformations out of order, the final result looks way wrong. There is a correct order. There are a lot of incorrect orders. So our correct order is going to be state everything horizontal first and then state everything vertical. Also keep in mind, as you're stating these, work your way from left to right. So within pink, go left to right. Jump to the outside. Within blue, go left to right. So you can memorize the acronym. That'll like guarantee you to get horizontal first every single time. If you're terrible at memorizing, then how about this? I keep saying think pink. That means do the pink first. Think pink. Or, and if you're a feminist, don't get upset with me for saying this, but back in my day, maybe even before my days, my mom, she's like your grandma, okay? When my mom was a lady, and my mom would be walking into a store, and she would be walking into a store the same time that a man would be walking into the store, what happened? You know what happened. The man opened the door for her. What do you think she did? Did she throw a fit and say, I can get the door for myself? No, she was very polite. So think about this. As he opened the door, what do you think he said to her? Ladies first. And she said, thank you. And she walked in the door. It's how we used to be. It's how society used to be. A man would open the door for you and say, ladies first. So, I'm going to think back to like grandma days, and ladies first, pink first, then blue. Okay? All right, and then, so that's got to be memorized, the order that you list the transformations. And notice, every time I listed transformations, if there were some pink and some blue, look what always came first. I always did the pink first. Pink first, pink first, ladies first. Now, on these last ones, I wrote a lot. So again, this might be a place where after each example, you might need to pause it and copy down what I have. I don't know. But so this was very vague. It said, suppose you have a function. Don't know what it is, don't care what it is. If you look at the black drawing, who knows what that thing was, okay? Suppose you have a function, and suppose there's a number outside the function. Not inside where the x is, but outside, like out in front, like a coefficient out in front. So I colored it blue. So when you have a number outside this function, we're calling the new function that it makes g of x. Let's take f of x. Let's multiply all the y's by 2, and we'll call it g of x. So I colored it 2 in blue because it's on the outside. I stated that it's a vertical stretch of 2. Now, here's what I did. I wrote, see the black graph that's on your paper, that was originally on your paper? I wrote down all those points. These are my original points. Then I did this to my points. Just to the y's, though. Vertical. Just to the y's. So instead of these y's, now I'm using these y's. Then I grabbed a different color pen and I graphed them. I graphed them in green. So I graphed the point -4, 4, and so on. So take a look, think about what color you need to make the extra information. What color are you going to make it? And then think about what's that going to do to your existing ordered pairs. Let's do the next one. There's some function named f of x. See where the x is? See how the +2 is inside with the x? I color-coded all of that pink. And then anything on the outside, I color-coded it blue. So what does the pink do? Well, it's backwards from what you would think. What does the blue do? Vertical, what you see is what you get. So I need to go left 2 and up 3. So same original. Same original. Went ahead and wrote them down again. And then I did that to them. I took left 2, left 2, left 2, left 2, left 2. And for the y's, I went up 3, up 3, up 3, up 3. I took my new ordered pairs, got my green marker, graphed them. -6, 5, and so on. Again, pause the video, copy it down, see if you've got it. Next one. See how this is inside the function? So whatever my x's were, make them the opposite. Those are my original x's. Now, throw a negative on them. Throw a negative on that one. What's it look like? There it is. Throw a negative on that one. What's it look like? There it is. Got my new ordered pairs, picked up by green marker, and graphed it. Look. It's a horizontal flip. What was over here is now over here. What was over here is now over here. Horizontal flip. And this one, the 2 is on the inside, backwards from what you would think. So I'm going to turn the 2 upside down. Horizontal compression by 1/2. So multiply my x's by 1/2. There are my original x's. There are my new x's. I didn't change the y's. Notice I didn't color anything blue on this problem. The y's aren't going to change. Only the x's change. There was only pink stuff going on. That's it. All right. Good luck. Hope this works well, and start memorizing those. Start memorizing your parent functions.